Gentlemen, how are you doing? All right. Yeah, I'm a little exhausted myself. Okay. We have 812 today. This is our last lesson, you guys. You guys have a test on Friday. This is the last lesson. Tomorrow we're doing like an around the room math lib thing on volume and surface area. And if you don't want to walk around the room, that's fine. It's on your Google Classroom, and you can do it in your seat. That's also fine, okay? So we have that tomorrow, and then you'll be able to also start your review for your test on Friday, okay? So today we're talking about spheres, and we have, again, a couple of formulas for the volume of a sphere. And again, where are all of these formulas located? On the very front page, ladies and gentlemen. So you have the sphere right here and the volume and surface area formulas right on that front page. Are those things that should go on a note card for your test? Yeah, absolutely. Okay. Surface area for other shapes with flat sides, rectangles and triangles and trapezoids, you're going to need those area formulas, but maybe not the surface area formulas because you can just add up all the shapes. Okay. So parts of a sphere. So we have a nice little sphere here, and this dotted line that goes all the way through the sphere from top to bottom. Oh, maybe I should highlight that. So this one goes from top to bottom through the center of the sphere is called a diameter. Just like we have a diameter of a circle, we have a diameter of a sphere, and it goes through the center. This is the center, the big dot right in the center. That'd be like the Earth's core. You know, it's the very center of the sphere, all right? So you gotta, know the center. The diameter goes through the center, top to bottom, the whole length. And then we have just this little bit that goes from the center to the edge of the sphere. What's that called? The radius, absolutely. Just like in a circle, the radius goes from the center to the edge. The radius goes from the center to the Earth's crust. All right, that is the radius. And then we have what is called the great circle. That is like the Earth's equator. It goes all the way around the sphere. So that dotted line that goes all the way around, that is called the great circle. The great circle slices the sphere into two hemispheres. And it looks a lot like circumference. It goes all the way around, okay? So that might be something we want to keep in mind. All right, so we have a couple of formulas for volume and surface area of a sphere. And you can see them here. The volume of a sphere is 4/3 pi r cubed. So, again, really nice formula. And we also have surface area is 4 pi r squared. Have you guys, surface area is an interesting one. How many of you have played baseball or softball? All right, baseball or softball. So you know how your baseball or softball is sewn together, right? And it's sewn together, and the seam they sort of mesh into one like this, okay? And what happens if you were to cut off those stitches and take off the leather wrapping, you get a shape that looks like this. Let me show you. I meant to copy it in here, but it's a shape that looks like this. It's sort of like that. They're sort of circular in shape, right? There's two of these sort of it's really hard to draw, and I should have copied the picture in, but I didn't. I apologize. Okay, so what it is, there's these two sort of rounded and stretched sort of spheres, and you can sort of imagine that if that ball, it would be essentially each piece of leather is essentially two circles of surface area. And so that is sort of how you can think about how did they get 4 pi r squared? Again, pi r squared is just the area of a circle. When you take that leather off the softball or baseball, you'll essentially get like 1, 2, 3, 4 circles, approximately. Anyway, that's what it turns out to be. That's what it looks like too. I'll pull up a better picture of that for you after notes, but it's pretty interesting, and I thought that was really cool when I saw that. I was like, oh yeah, that's a cool way to think about it. All right, so we got a couple formulas here. Right now we want to find the volume of each sphere round to the nearest tenth. So we want volume, and what is this 4 inches for? That is our radius. The radius is 4 inches, so we get to use our formula, 4/3 pi radius cubed. This is radius cubed. All right, go ahead and plug that into your calculator. 4/3, not 63. Pi times 4 to the third. 268.1. And this is inches cubed because, again, we're talking about volume. And we're taking right here, this is 4 inches. 4 inches. And if we take inches and do inches times inches times inches, that would be inches cubed. Okay, so we're cubing our inches. All right. Number 3, what is our radius on number 3? 13. How'd you get 13? 26 divided by 2. Good. So we get 13 millimeters. Oh my gosh. All right. And so we want the volume. The volume is 4/3 times pi times radius cubed. 4/3 pi radius cubed. 9,202.8. Millimeters cubed. On number 4, what's the radius? Radius is 5.5. Good. I'm not going to do that one, but again, they're giving you a diameter top to bottom, so our radius is our diameter divided by 2. Okay, questions on those? Formulas are easy, right? Yep, okay, great. So now we move to surface area. So reading our directions carefully, surface area of a sphere. Surface area of a sphere. 4 pi r squared. What's our radius here? 7. So surface area is 4 pi radius squared. So we get 4 times pi times 7 squared. Round to the nearest tenth. Good. 615.8, and this is miles squared. And again, you can see it right here. Why is it miles squared? Because it was 7 miles to the second power. So that's miles times miles, which is miles squared. Good so far? Formula is so easy. All right, turn the page. Let's do number 8, and then we're going to do a couple of applications. Number 8, what's our radius going to be? 13.3? 8.3. Okay, so 16.6 divided by 2. 16 divided by 2 is 8. 6 divided by 2 is 3, so 8.3. All right, surface area. What was the formula? 4 pi times the radius squared. 4 pi times the radius squared. All right, who's got me an answer? 865 point. All right, 865.7. Thank you. Feet squared. Beautiful. All right. Let's look at number 9. The length of a diameter. Oh, find the length of a diameter of a sphere with a surface area of 1,017 and 0.88 square millimeters. What do you think we need to do to be able to find a diameter? we will need to double a radius. Good. What do they want us to do? They gave us the surface area number. So this is a sort of backwards process one. Normally we have the radius, but they're giving us this answer. What do you suppose we need to do? Yeah, we've got to go backwards. We're going to set this up to solve an equation. So I know that I'm talking about surface area. I'm going to write down my formula. Surface area of a sphere. What's the formula for surface area of a sphere? 4 pi radius squared, right? All right, we're going to plug in what we know. So what information do we know? The surface area. So I'm going to put this in and place the surface area. 1017.88 equals 4 pi radius squared. All right, and this is going to allow us to solve for r. What should we do here? We need to divide by 4 and pi. We can divide by both of them, but you do have to be really careful on your calculator. So please, everybody, let's follow along here. We're going to divide by 4 pi, and then, so in your calculator, there's one way that always works. So this is a nice little fraction setup right here. So let's also do a fraction setup. That's alpha F1. So do alpha F1, and this is numerator denominator setup. All right, have you seen that before? Okay, alpha F1, and we're going to do 1017.88 on top, and what's on bottom? 4 pi, so I went alpha, right here, F1, and numerator denominator, alpha F1. Find it? Yeah, you there? Okay, alpha F1. It says numerator denominator. I'll do it again. There you go. Right there, number 1, numerator denominator. Okay. All right, and then once you put that in, then you can hit it, and we see that we get 81 equals the radius squared. What number squared is 81? 9, yeah, r equals 9. Hey, did they want the radius? No, what did they want? Diameter. So how do we get diameter? Double it. 9 times 2 is 18 millimeters. You don't have to use alpha F1. If you didn't want to use alpha F1, then I can also get it by putting parentheses around the whole denominator. So 1017.88 divided by 4 pi. But if you put parentheses, that's telling the calculator divide by both of these. All right, and I'm going to get the same answer. So you can just use parentheses, which I think is a lot faster. That's what I use all the time. Okay? Let's look at number 11. This is kind of an interesting question. Number 11. Oh, maybe I want to do number 10. That's really interesting, too. All right, we're going to do number 10 as well, but we're going to start with 11. A standard basketball has a circumference of 94.25 inches. How much leather material was used to make the basketball? All right, so first of all, if they're asking how much leather material, what are they talking about? The surface area, yeah? So how much leather material? They want to know the surface area. All right, do I know a formula for surface area? Yeah, the surface area is what? 4 pi r squared, very good. But they didn't give us the radius. What information did they give us? They gave us circumference. Okay, so I'm going to use that to get started. Tell me something about circumference. Very good. Circumference equals 2 times pi times radius. What information did they tell us? Where do I plug it in? Then to the C. Very good. So we're going to plug in circumference. They told us it was 94.25 equals 2 pi r. So what do we need to do? Divide by 2 pi, just like we did before. I want to get r by itself, so we're going to divide by 2 pi. What do I need to do with that 2 pi? We got to make sure we're dividing both. So I'm going to put parentheses around it so that I divide everything there. 94.25 divided by the 2 and the pi. And I get 15 even. All right, so now we know our radius. What do I do with the radius? Plug it in for our surface area formula. So 4 pi times my radius squared. Yeah, very good. 2,827.4 inches squared. So that was like a two-stepper. But I love that we did the divide by 2 pi and divide by 4 pi. Again, those parentheses are important in your calculator. Without those parentheses, watch what happens. Divided by 2 pi, I get a much larger number. Okay? Huge number. And the reason is when your calculator reads this, it says, okay, 94.25 divided by 2. Well, that's like 46. All right? And then multiplied by pi. So that's how it's reading it. So they took 46 and multiplied it by 3.5. All right? So you have to be very careful. This says we're dividing all of the 2 pi. All right? So it's a very different thing. So it's really important you understand how your calculator works. Let's look at number 10, then we're done. 4 glass balls, each with a 2.5-inch radius. So that's important. I'm going to underline that. Are placed in a box. If the remaining space is to be filled with cotton for padding, how much cotton is needed? If they're asking how much cotton is needed, what is that a measure of? Volume. Yeah, they want to know the volume. V-O-L-U-M-E. Okay. They want to know the volume of the material, how much is going to fill it up. Okay? Well, how are we going to figure out? No, not quite. Times 8. 1, 2, 3, 4, 5, 6. Oh, I see where you got that. That's good. Okay. So we've got these nice big glass things in there. How are we going to figure out, like, we just need the cotton to go into little vacant spaces. How do we find how much vacant spaces there are? Subtract. Very good. We need to subtract what? The volume? The volume of the circles from what? The volume of the box. Yeah, so we want the volume of the box minus the volume of the glass spheres, okay? And so we need to figure out a few things. So first of all, they told us that we have a 2.5-inch radius. So right from here to here is 2.5. So how long would this whole thing be then? How'd you get 20? Yeah, so if we go from the radius is 2.5, then the whole diameter would be 5. So we've got 5 plus 5 plus 5 plus 5. So we get the whole thing would be 20 units long. All right. How many units front to back here? 5 as well. And then how tall would it be? 5 as well, again, because that diameter goes through the center. It's also 2.5, and 2.5 makes 5. So how do we find the volume of the box? Yeah, so 20 times 5 times 5, length times width times height. So that's our volume of our box. And how do we find the volume of all the glass spheres? What is our volume formula for a sphere?
4 pi times radius cubed.
4 pi radius cubed. That's 1 sphere times 4. Very good. Very good. And what was our radius? 2.5. Okay. So 20 times 25 is 500. And then I have here 4 times 4 is going to be 16 times pi times 2.5 cubed. Oh, wait a minute. It's not 4. It's 4. Volume is 4/3. That's what we're missing. That's what we're missing. Volume is 4/3 pi r cubed. So this should be 4 times 4 is 16/3. All right. What? I heard what? I'm sorry.
No, you're good.
I'm sorry.
Why are we doing it by 3/8 like repeated?
The cube?
Yeah.
Because this is the volume of the sphere. The volume of a sphere was 4/3 pi radius cubed. Yeah? All right. Are we with ourselves now? We're all together? 500 minus 16 over 3 times pi times 2.5 to the 3rd power? There we go. 238.2 inches cubed.
Are we done?
Yeah, you're done. And you have a worksheet today.
No, I'm so excited.
Keep those notes handy. Keep those formulas handy.
Wait, do we go with the packet? No, any more to do. Absolutely. I'm gonna get a note card. Morgan, what's your win? Me too. You wanna do it? What? I can't change it. No, I couldn't. Okay, yeah. Football 101. But it'll be less study. Yeah, so maybe we can do our work. Oh, there's no back.